Welcome to video 150 in series 3, and now I'll complete the NPC state patrol script. Okay, so open up the NPC state patrol, and first of all put in the variables private read only NPC state pattern NPC, private int next waypoint, private collider and array colliders, private vector 3 look at point, private vector 3 heading, private float dot prod, so dot product. So we have here public NPC state underscore patrol. That's a reference to this script right here, and it takes in a parameter of the type NPC state pattern, and I'll just call that NPC state pattern. And inside of it, NPC, this variable, is assigned a reference to NPC state pattern. So now we can initialize this script. So in the NPC state pattern, we have these here set up state references. So let's do that. So I'll put in there patrol state is equal to new NPC state patrol this. So we create a new instance of the NPC state patrol script and supply it with a reference to this state pattern so that we can control it from this state pattern. Okay, so save that and save the other script as well. So if without that portion of code, an error would definitely show up. Okay, that's good. So now that we've established that, inside of the update state, I'd like to put in two new methods that we haven't written yet. So they're look and patrol. This is a very big script, by the way, so we've got plenty to write, plenty of sub methods as well. And under toAlertState, I will put here npc.currentState is equal to npc.alertState. So that just transitions over to the alert state. We won't use any of the others, but you have to leave them there since the interface requires that. Okay, I'll start by putting in two sub-methods. First of all, void alert state actions, parameter, pass in the parameter, transform, target, npc.location of interest is equal to target.position, and then toAlertState. state. So this is quite simply just some action for capturing the location of interest, which will be used by the alert state script, not this one. The next one is void visibility calculations. Again, pass in a transform, and just call it target. The variable look at point, which we had up here. Look at point is equal to new vector 3 target.position.x, comma target.position.y plus an offset value npc.offset, because some models, some game objects will be all the way at the feet. So we don't want, when we're raycasting, we want the NPC to look somewhere not at the ground, but rather look a bit higher up so that they can see their potential targets, because they could be anything, a low wall or whatever object on the ground. If they're looking towards the ground, well, that doesn't really help. And just to, I guess, make that clearer, like for example, the enemy golem has, for example, its point of origin at its feet. So that's what I mean. Otherwise, another golem will look down to the ground at the foot there, and that's not so preferable. Okay, and then comma target.position.z. A heading is equal to look at point minus npc transform.position dot prod. So the dot product is equal to vector 3 dot dot, the vector heading, comma the vector npc dot transform dot forward. And we're going to use that to determine, first of all, look at point is for our line cast that we'll have, and dot product is used to determine if the potential target is actually in front of this NPC. Okay, I'll now put in the look method. I'll just put it up above. Okay, so void look. First of all, check medium range. I use an overlap sphere, so this array colliders captures whatever's hit by the overlap sphere. Physics.overlap_sphere, starting from npc.transform.position, comma npc.siteRange divided by 3, that's the radius, comma npc.myEnemyLayer. So only look for enemies. The overlap sphere is efficient and will only contact enemy things that are on the enemy layer. If colliders.length is greater than 0, so we've actually captured something, visibility calculations collider 0.transform, and if dot product, so if the thing of interest is in front of us, then in front of this NPC, then do the alert state action. So this position will be captured as a position of interest, and the NPC will move into the alert state. Okay, so now for checking max range, again overlap sphere, but without the divide by 3, so that's just physics.overlap sphere, npc.transform.position, comma, npc.siteRange, comma, npc.myEnemyLayers. Now go through each of the captured colliders, the array, for each collider, col in colliders. So the first one is just simple, only just check for something really close by. And there's no need to do all this slower sort of code stuff, so I just do something really quick. And oh, by the way, I should have said return here. So once the alert state actions are done, return, so that we don't do all the rest of this code wasting time for no reason. So just return, get out of this method. But anyway, if that's not satisfied, then we do the max range check. And for each collider, col in colliders, create a raycast, so raycast hit. Visibility calculations on that col.transform, if physics.linecast from npc head.position to look at point, out hit, so get some information out, comma, npc.siteLayers. SiteLayers, as you know, was everything except the ignore raycast layer and whatever layer this particular NPC is on. So enemies will not have their vision blocked by their allies. They will be able to see, or they will cast out a line cast all the way to whatever is of interest. So if there's a large group of them, on the first few won't be the ones who do everything, and the others, are all stuck behind thinking they can't see anything. Okay. For each string tags in npc.myEnemyTags, so there could be any number of enemy tags, you can set up whatever factions you feel like. So if hit.transform.compare tags, so yep, it's found a matching tag. If the collider that was detected was in front, then, and that's where the dot product check comes in, then we do the alert state actions, pass in this transform, and of course the location of interest is then captured, and the alert state script will take care of the rest and just jump out of the method. Okay, finish. And there's no need to continue iterating because we've found a suitable target, so that just bumps out immediately. Okay, so that's the look method done. Now still lots more to do. I have another sub method here. This one is bool random wander target, a vector3 center, comma, float range, comma, out vector3 result. So we're going to pass in the wander target to get filled in, and then this will return a possible place for the NPC to wander to if it has no waypoints. So first of all, nav mesh hit. Nav hit, vector3, random point is equal to center plus random.inside unit sphere times npc.siteRange. So we've just picked a random point somewhere for us to get a nav mesh position, which is the next thing we're doing. If nav mesh.sample position this random point, so random point, comma, out nav hit, comma, 3, comma, nav mesh.all areas. So what I'm trying to do here is trying to find somewhere on the nav mesh, the baked nav mesh that is valid, that the NPC can wander to. And I just use an area of 3, so it samples a fair amount of area to find a valid position to go to. So result is equal to nav hit dot position, return true, otherwise result is equal to center, means don't go anywhere, and return false. Okay, so it won't wander from where it currently is until the next carrying out of this method. Okay, so the next sub method is bool have I reached destination. Now I've got some more methods to write. If npc.mynavmeshagent.remaining distance is less than or equal to npc.mynavmeshagent.stopping distance and not npc.mynavmeshagent.pathbending, then stop walking. What this is saying is that if the NPC has reached reached its stopping, it has reached its waypoint or whatever, so it's less than or equal to the stopping distance, so the remaining distance is less than or equal to the stopping distance, so that means it's reached its target, and it doesn't have somewhere else to go to. So it takes some time for a new path to be calculated. So just make sure, first of all, just check that it isn't calculating a new path somewhere and trying to figure out a new place to go to. Otherwise, you will inadvertently stop it from being able to go to places that it needs to go to, and it will stop walking. So stop walking, return true. Otherwise, keep walking, return false. Right, the next sub method is void move to vector3 target pos. If vector3.distance npc.transform.position, target pos greater than npc.mynavmeshagent.stopping_distance plus 1, then we do npc.mynavmeshagent.setDestination, that's applied target pos, keep walking. What this is about is that first of all, it's telling the nav mesh agent to set a new destination, but it's also saying, why am I doing this stopping distance plus 1? So for example, the golem has a stopping distance of 3, plus 1 gives 4. I'm trying to say that don't walk meaninglessly short distances. So when you do, for example, a wander, get a wander position to go to, it could be really close. It could be 0.5 meters away. There's no point moving to 0.5 meters. It'll look very funny if the NPC moves a very short distance and the animation kicks in for just a little bit for seemingly pointless goal. So this stops that kind of unpleasant looking sort of movement. Okay, let's do the keep walking and stop walking methods. Void keep walking npc.mynavmeshagent.resume npc.npcmaster.call event npc walk anim. Then void stop walking npc.mynavmeshagent.stop npc.npcmaster.call event npc idle anim. So very simple, very simple that. Okay, so that just leaves the next main method. So after doing look, patrol. Void patrol npc.meshrendererFlag.material.color is equal to color.green. If npc.myFollowTarget is not equal to null, then npc.currentState is equal to npc.followState. So initially, when the state pattern starts up, it will put the NPC in the patrol state. But if they have someone to follow, so like friendly AIs can follow the player, then they will immediately move over to the follow state. If not npc.mynavmeshagent.enabled, then just return. There's no point doing anything if the nav mesh agent is not enabled. It'll just return errors. If npc.waypoints.length is greater than 0, so we have waypoints, then move to the very first waypoint, whatever the value of next waypoint is in this array. So let's say, for example, there are 4 waypoints. We first of all check, have I reached destination? Then we can determine the next waypoint counter to go to. So this is next waypoint is equal to brackets next waypoint plus 1 modulo npc.waypoints.length. So this is a very clever bit of code that the Unity guys use in one of their tutorials. And what's happening here is, for example, let's say we've done waypoint 0, so next waypoint was equal to 0, and we went to the first waypoint in the list, in the array. So then, yes, have I reached destination will be true, and then so this 0 plus 1 will then be 1 modulo, and let's say there are 4 waypoints altogether, npc.waypoints.length is equal to 4, so 1 modulo 4 will return 1. So then next time we come to this code, it will go to the entry index 1 in the array. And once the NPCs reach that position, so it will now be 1 plus 1, which is 2 modulo 4, will return 2. And so next waypoint will be equal to 2. Okay, so it'll go to that next index in the array. Once again, so 2 plus 1, so it becomes 3. 3 modulo 4 returns 3. And it'll then go to waypoint 3. Once it's done that, so 3 plus 1, so 4 modulo 4 will return 0. So it will reset, and that way it'll start going back to the first waypoint. So very nice, simple code there. Okay, now so if npc.waypoints.length was greater than 0, that was this if block. Now if it wasn't, so else wander about if there are no waypoints. So if have I reached destination, stop walking, so whatever it was. If random wander target, brackets npc, so that method that we just wrote below, let's apply it, npc.transform.position, comma, npc.siteRange, comma, out npc.wanderTarget. So fill in this variable, please, is what we're saying, and then move to npc wanderTarget. So very nice and easy. Let's save all of that. Let me just scroll through slowly so you can see it all completed. So we've got our update state. We didn't use a lot of the mandatory methods that are required by the interface. There's our look method. Okay, so basically the NPC looks, can it see a target? If it can, then it will move to the alert state. If it doesn't see anything anyway, it'll just continue patrolling is what it is doing. So that's our patrol method. We have our alert state actions, all these sub methods here. And I'll just keep scrolling. Yeah, it was a lot of work done here. We've written quite a long script. It's one of the longer scripts. So let's go back to Unity. Okay, all good. We can set up a little bit. It will, like if we set up the golem with some of the things that's required, it will start patrolling around. But if it detects the player, it'll want to go to the alert state, and then it will throw up an error. So let's just see. Let's just set a few things up. Okay. First of all, it needs the NPC master, a reference to that. I put that there. I didn't do get component by script. I just had this hard reference here, this permanent reference here, so to make sure it absolutely finds it in the code, so there's no script execution problems, or less likely anyway. And then the head of the golem, we need to tell it what that is. It's necessary for the raycasting. Mesh renderer flag. Okay, what can we do here? Let's add a cube. So create 3D object cube, raise it up, say 1.5, oh, much higher than that. Make it a lot smaller, make it like 0.4, 0.4, raise it up some more, 3.5. Okay, that should do it. State flag, and I'll just give it a name. I'll just call it state flag. It doesn't need a collider, so get rid of the collider component. It needs the mesh renderer, but don't have any shadows, no point in all of that. Good, and well, no light probes or anything, no reflections, okay? Not necessary. Okay, then going back to our golem, let's drop in the state flag. Okay, good. We don't have any. We don't have anything else. I'll just hit apply there that we can set at the moment. I'll just see something. If I could possibly. Okay. I'll just comment this alert state code out just for a moment, so it won't throw up an error. Well, I think it won't. Let's see what happens. All right. So there you go. He's patrolling. He's just wandering around. Our NPC. Now he's not going to do anything, he's just going to wander around. Of course he doesn't detect the player or care about the player because he's not going to go to the alert state, and we haven't written anything about alert state. Boy, he's really wandering around. Okay, well, oh yeah, I better, wait a minute, where is this guy going? Boy, he can really wander a big distance. Anyway, that's pretty cool. Right, so let's just stop that. And let's go back and let me uncomment that bit of code there. Good. And that should be pretty good. One thing I should point out is I think in the previous video I had put a player tag there. I had written a second player tag. So just delete that. That's not right. That was silly because there's already a player tag by default. Okay. Alright, anyway, that's it for this video. Next one, we need to keep on going and writing more behaviors.